Hey guys, we've got two things today, some a little bit of geometry at the end, but let's look at trinomial factoring. This is one of the major types of factoring that we do in Algebra 2. You have done this some before, but let's go back and review. Now let's go backwards first and see where we are, then we'll go from there to factor. So if we multiply two binomials like this, we'll do the x first and go x times x is x squared. X times -3, -3x. Done. 8 times x, 8x. 8 times -3, -24. Okay, so here we are. We've got an x squared. We have a 5x, and we have a -24. Now, if you look at this, what we're going to do from now on, which you've probably seen in Algebra 1 before, if you've done Saxon, you definitely have. But when we look at a trinomial like this, it's like a small puzzle. We will factor this into two binomials, which we already know what they are. We just saw them up here. And what we're going to do is go, okay, well, that's x squared. That's always going to be an x times an x. We need two numbers, that these same two numbers multiply to give us -24, just like they do here. And they also add to give us this coefficient of the middle x. Well, this is where if you need to, you can start going, okay, well, the two factors of -24. Well, since there's two numbers that multiply together to give me a negative, one has to be positive and one has to be negative. So you can start listing, okay, well, see, that's -12 times +2. Now, does -12 plus 2 add up to 5? No, it doesn't. Then you can just keep going through, and eventually you might see it right away, that, +8 and -3, those two numbers are the two factors that add up to give you 5 and multiply to give you a -24. Okay, so there are little tricks like that. Like, as soon as you see they multiply to give you a negative, you know it's going to be a positive and a negative. Let's say they multiply to give you a positive, but they add up to give you a negative. You know it's got to be two negatives, right? Multiplying to give you positive and adding to give you negative. Things like that. Okay, so let's do several of these. If you want to go ahead and pause and copy here. All right, first thing we need to do is put this in order. Let's go ahead and put it in descending exponent order. X squared minus 5x plus 6. Excuse me. So right away, don't even think about it. Just make this into two binomials, x and x. Now you got to think. You need two numbers that multiply to give you +6, and those same two numbers add to give you -5. Well, that's going to have to be two negative numbers if they multiply to give you positive and add to give you a negative. And of course, the answer is going to be -3 and -2. And again, it doesn't matter if you have x minus 3 here and then behind it x minus 2, doesn't matter. 8 times 7 is the same thing as 7 times 8. So just make sure you have the right sign in front of the right number. And in this case, it doesn't matter because they're both negative. Okay, here's another one. Now this is in the right order, descending exponent order, but we're not used to doing things with a negative x squared. We don't want that. We want to factor that out of it. So what we'll do is, this is like saying -1. So let's just say we're going to factor out a -1. Of course, if you wanted to, you could just factor out a negative. That's all you need to do. But let's just do -1 so we can see what it is. So once we pull out a -1, we divide all these terms by -1, we get x squared. And this time we get -5x and we get -14. Okay, so keep the -1 down there. And let's knock this into two binomials, x and x. Well, as soon as you see that two numbers multiply to give you a negative, you got to know one of them is negative and one of them is positive. Okay, those two numbers also add to give you -5. Well, the factors of 14 are really like 14 and 1. That ain't going to work. 7 and 2, and that'll work. 7 and 2 has to do with 5. So you can go, okay, if it adds up to give you -5, that'll be -7, and it'll be +2, and you can stop right there, and that's as far as you want to go. All right, here's another one. Pause and copy if you need to. Now this is kind of funky looking here. It's, number one, it's not in order. So let's just stick it in order first. -3x squared plus 6x plus 24. And number two, it's negative. I don't want that, so forget that. I'm pulling a negative out. So 3x squared minus 6x, make sure you do that, minus 24. And the third thing is, we're not used to dealing with x squareds that are anything other than with a coefficient of 1. So just pull out the 3. So you've already done the negative, so pull out the 3. So that's going to be x squared minus 2x, and then 24 divided by 3 is 8. And now we're ready. We're set. This is the part we got rid of, so we can kind of get that out of there. This is what we want to mess with. So keep the -3, and we need two numbers, of course, x and x. they multiply to give you a negative. So immediately you say, okay, a positive and a negative. They also add to give you -2. Well, what two factors of -8 add to give you -2? And the answer is +2 and -4. And there you go. Now in the back of the book, they might, for example, have this as an answer. -3 times x minus 4 times x plus 2. Well, that's okay. This is the same as that, and this is the same as that. And it doesn't matter what order you multiply things in. You know, 9 times 5 is 5 times 9, so who cares? Okay? All right, we'll try a couple more here. Now this is weird. Blah. Okay, we got 4 to the 4th power to the 3rd power. Ugh. We don't know what's going on here. Let's at least put them in right order. Okay, so a descending exponent order, -2x to the 4th, plus 12x to the 3rd, plus 32x to the 2nd. Well, what we can do is, since we do not know how to factor at this point anything other than something, you know, squared minus to the 1st power and then the constant, let's go ahead and factor out everything we can. First off, we know we don't want our first term to have a negative in it, so let's just pull out a negative. If you want to do this all at once, you can do all these steps at once, but I'll just do it for the heck of it here. So we got 2x to the 4th, minus 12x to the 3rd, minus 32x to the 2nd, okay? Now, if you look at all three of those terms, you can pull out an x squared out of all three of those. So let's go ahead and do that. We've already done the negative, so let's just put the x squared. All right, so that's going to be 2x and then x to the 4th divided by x squared is x to the 2nd, minus 12x to the 1st, minus 32, and that's just it, 32. There we go. All right. But again, we're not used to doing a 2 in the beginning here with the coefficient of the x squared. So let's go ahead and pull out a 2 as well. And now we have x squared minus 6x minus 16. Now we're in good shape because we have a trinomial, which is what we're doing, trinomial factoring. The coefficient of the x squared is a 1, and then we're ready to go. So this is our last step. So all we need now are two numbers that multiply to give you -16. So immediately that's going to be a plus and a minus. They also add to give us -6. Now if you piddle around through it, you would find that the answer is +2 and -8. And this is, in fact, your final factoring. Okay, and that's it. All right. Let's look at the geometry part. This is even kind of weirder. These overlapping right triangles. We're going to get into some odd things, but the concept is exactly the same. There's only one little extra thing we're going to be doing at the very end to figure the answer out. But if you were to bust this up into pieces, the small piece would be, you know, it would be this triangle here, right? And it would be a B here, it'd be an E here, and so on. Now, the huge triangle, like the bigger one, like the one it is, the top side would be B plus C, the right would be D, and the bottom would be E plus F, right? Now, you know, you don't have to know what all those are. We don't care. All we care about is that we have one triangle, a second triangle. We set them up as ratios, this side to that side to that side, boom, and then we've got it, okay? And you'll see something kind of unusual happens with this one. So if you want to pause and copy, I'd pause and copy and draw this triangle somewhat, you know, decent looking. Okay, well, let's take a look. Find A, B, and C. So let's just go ahead, and I'm going to write these two triangles like this. I'm going to make them small so I have room to piddle around with this on the piece of paper. So the small triangle is A. That pathetic bottom curved side should be thrown to the garbage can, or at least forced to watch golf on TV. Okay, there's the second triangle. Now let's do this. This side is C. You see that? The bottom is what of the big triangle? 10, right? 6 plus 4. Okay, the left side is A plus B. I'll stop right there. Okay, that makes sense? Okay, so we're going to have to do a couple of steps on this one. Well, if you look at these two little triangles now, forget the big one. Look at these two triangles we're piddling around with. There's really only one side we can find right now, just with the ratios we have, and that's side C. Because if you look, you can't go, oh, A to 6 is A plus B, or wait, that gives you two different variables. You can't solve an equation like that. You need one variable with a fraction equals fraction. So we're going to go ahead and say 6 to 4 is 10 to C, or 4 to C is 6 to 10, whatever. You make sure you're consistent. So, you know what? I'll just do the right to the bottom. So 4 to 6 is equal to, okay, right to bottom equals right to bottom. So C to 10. So 6 times C is 6C. 4 times 10 is 40. And divide by 6. And that'll be 40 over 6. That reduces to 20 over 3. And I'll stop right there. We have found C. Now we need to find A and B. All right. Well, let's just go ahead and write in the value for C over here on the right. So I'm going to erase this. And I'm going to write, instead of C, I'm going to write 20 over 3. Because that's what we found out what it is. Okay? All right. Now what can we do? Let's take a look at this. Think with me, and what can we do? Okay, and the answer is we can find A by a special method that we've used before, but we haven't used with these similar triangles before. And that's the Pythagorean Theorem. Remember that? 6 squared plus 4 squared equals A squared. So that's what we're going to do. So we're going to go A squared is equal to 4 squared, 16, plus 6 squared, 36. So A squared is equal to 52. So A is going to be the square root of 52. Now we don't just leave it like that. We want to see if we can bust this thing down. So again, if you ever forget, go ahead and use the factor tree. So you can use, I'll just kind of go up here and do it. So 52 gets broken up into, you know it's going to be 2 because it's an even number. There's a 26 if you do the arithmetic. 26 breaks up into 2 and 13. So the square root of 52 turns out to be 2 times 2 times 13. All right, we know that 2 times 2 is 4. If something is doubled underneath the radical, it can be pulled out as 1. So A turns out to be 2 times the square root of 13. Got it? Okay. It's not something you normally think of because we haven't used it with those similar triangles at this point. But let's go ahead and start using it. So we have A as 2 times the square root of 13. All right. So we found A. We found C. Now we need to find B. Well, all we need to do now is just go ahead and put the 2 times the square root of 13 right in there for A as well, because that side length is A plus B. So yoink, that's, oops, does that bother anybody who's OCD? Can I just leave it there? I'll erase it. Okay, we'll do it there. Okay, so there's my, oops. 2 times the square root of 13 plus B. Okay, well, now it's a piece of cake. We just go, okay, this to this, like the top to the bottom is, let's say left, is the left to the bottom. So let's just do it over here. You know, let me do a different color so it stands out a little bit here. So here we go. Okay, so we have 2 square root of 13 to 6 equals 2 square root of 13 plus B to 10, right? Same process now, cross multiply. So let's go over here and get the B first. So we're going to distribute. I'll go ahead and do that. I'll copy it out so you see what's happening. Okay, this times that is equal to 2 square root of 13 times 10. Well, 2 times 10 is just 20. That's going to be a square root of 13 right there. Okay, let's distribute. 6 times 2 square root of 13 is 12 square root of 13 plus 6b. That equals 20 square root of 13. All right, this is a like term that needs to be shoved over there. So if we do the shoving, we got 6b. We got 20 square root of 13 minus 12 square root of 13. That gives us 8 square root of 13. All right. The last thing we do to solve for b is to divide by 6. There she blows. And since these two numbers are divisible by 2, you can reduce that. And that'll be 4 square root of 13 over 3. And that is the side length of b. Okay. Really very quick summary. We've done exactly the same thing. We figured out, okay, these are our two, similar triangles. We drew them up as best we could. We used the Pythagorean Theorem to find one of these. This time it was the A. We used the, ratios to find the other one, C. The only thing that's kind of a little funky is this last one with B, because you're going to have to piddle around. First off, well, with the A, you're going to have to figure out, can I knock down that square root of 52 or square root of 108 or whatever you get? Can you knock it down? To find out if you can, go ahead and factor tree it and down. Every pair, move it out there. Once you figure out what that A is using the Pythagorean theorem, you do exactly the same thing. You go this to this is this to that. You could have done left to this equals 6 over 10. We didn't do that, but we could have, so as long as you're consistent. Okay, all right, let's try practice problem A. Pause it and come back when you're done. All right, wrong order. So let's put this in the right order. X squared minus 6x minus 7. Okay, well this ought to be pretty easy. All right, we got an x here and x here. We have factors of negative 7. Okay, well if two numbers multiply to give you a negative 7, one of them's positive, one of them's negative. And they also add to give you negative 6. That means we're going to have a negative 7 plus 1, and there you go. And if you wrote x minus 7 times x plus 1, obviously that's okay as well. Okay, pause it and try B. Okay, the wonky part of this is the negative in front, so let's get rid of that. So I got to take out the negative 1. So that's going to be x squared, and then 6x divided by negative 1 is negative 6x, and 16 divided by negative 1 is negative 16. All right, so keep our negative 1, and I need two numbers here that multiply to give me negative 16, which means that's going to be negative and a positive. And they also add to give me negative 6, so that'll be, let's see, negative 8 and positive 2, and there you go. And of course, if you have these two reversed, that's okay, as long as the plus stays with the 2 and the negative stays with the 8. Okay. All right, go ahead and let's do C. Go ahead and pause it and try C. Okay, wrong order already, so I'm just going to do this. Negative 3x to the 4th. Plus 21x to the 3rd, plus 24x to the 2nd, okay? I'm pulling out my, I'm just going to pull out a negative 3. You know what? I'm going to do the whole thing. I'm pulling out a negative, I'm pulling out a 3, and I'm pulling out an x squared all in one chunk. How about that? So this divided by this will be 1. X to the 4th divided by x to the 2nd is x to the 2nd, and a negative divided by negative is a positive, so we're good. Positive divided by negative is a negative. 21 divided by 3, 7. X cubed divided by x squared is x. Done. A positive divided by negative here is a negative. 24 divided by 3, 8. X squared divided by x squared, yoink, nothing. It's just 1. Okay, now we're in good shape. Now we've got this going. All right, keep your negative 3x squared. Just copy it right down, and let's knock out these two binomials. So here and there. Okay, they multiply and give you a negative, so immediately that's a positive and negative. They also add to give you negative 7. Well, that's going to have to be negative 8, right? Plus 1, and there you go. That is it. Okay. All right. Pause it. Let's try the last one, which is D. And if you struggle a little bit, come on back and let's, join up and do it together. But don't forget, we're going to use Pythagorean Theorem for the smaller one to find A. We're going to use just the normal ratios to find C. Then we're going to use that square root junk to find B. So, all right, give it a whirl. All right, I'm going to go ahead and write I'll just make both of these triangles again right here. Doesn't matter what shape they are at all. All you need to do is get yourself set up so they look nice so you can kind of do a ratio with them. Okay, so this is going to be A plus B, and I'll close that. That'll be 8 on the bottom and C to the right. Okay, well, let's do the Pythagorean theorem first. Might as well. So we got A squared is going to be equal to, equal to 4 squared plus 5 squared. Okay, so that's going to be A squared is 41. Of course, then be A is the square root of 41. Yoink. That's kind of a freaky number. All right, I'm just going to erase this. We're going to go with square root of 41 right here, which will be just, I can tell, oodles of fun to piddle around with. All right, good enough. We got our A. Check. Let's go ahead and do C, because that's a piece of cake, right? 4 to 5 is C to 8. That's easy, right? So 4 to 5 is C to 8. So cross multiply, 5 times C is equal to 4 times 8. And then C is going to be 32 divided by 5, and that's good enough right there. Okay. All right. Well, don't forget, once we found out what A was, we can chuck it right there as well. So let's go ahead and start chucking here. Yoink. And square root of 41 there. Okay, now we can find B. I'm going to go ahead and put 32 over 5 over here for C. Okay. All right. Well, let's go ahead and do, we're going to find B, so we have to use this side. You could do this one to this one equals that one to that one, or you could do left to left equals bottom to bottom. Who cares? Whatever. Let's just do left to left, whatever. Okay, so square root of 41 to left to left, square root of 41 plus B equals, so this to this is 5 to 8. So 5 to 8. All right, well, let's do this first then. So the square root of 41 plus B times 5. I'm just going to go ahead and write this out so we can visualize this a little bit better. Okay, got that. That equals 8 times the square root of 41, okay, which is 8 times the square root of 41. All right, distribute 5 square root of 41 plus 5b equals 8 square root of 41. This gets clopped over there, and when you're done clopping, you got 8 square root of 41 minus, that's going to be 3 square root of 41. And the last thing you do is divide by 5, and there is your answer. Here you go. That's all there is to it. Okay. All right. Hope that went well. Give those a good whirl today, and keep at this stuff. If you're getting 20 right answers, look at what problem set we're on. We're on 26. If you're getting 20 answers right out of 30, you're getting 2/3 or almost half of them right. I mean, getting 20 answers right, even if you've done 26 problem sets, that's pretty good. Keep at it till you can get about 25 or 27. One of these days you might get 28 or 29, and once in a lifetime you might get 30 out of 30. But you're doing a good job. Just keep at it. Don't give up. You should have at this point some of the problems in the problem sets that you kind of zoink right through. Some of them are challenging. Don't worry about it. Go back and look at your notes and get them right. And at the end of the year, you'll have a chunk of stuff that you've done right, and you can be proud of that. So anyway, all right. Have a great rest of the day, and see you guys next time. Take care.